Having tried it with learners, groups of teachers and trainers shared their observations.
It can be taken through a number of stages, to very simple recognition of magnetic fields and interaction, to quite complex.
In discussing it, they explored each other's approach to describing the effect.
Do they understand where the north and south is on that battery may be flat?
A combination of diagrams, words and gesticulations.
And this is sort of getting them thinking about motors.
There were different conventions and different interpretations, leading to ideas about how learners could be helped to explain their thinking.
Maybe a solution to students revealing their understanding of this phenomenon is actually to make a three-dimensional model.
Building models was one of many suggestions. Another involved listening to the kinds of conversations that emerged between learners as they explained it to each other, and thinking about how to respond.
Where are we going to?
Ivan and his colleague Roger agreed to explore this idea further. They also agreed to be filmed.
Would you care to draw a card? Any card? They're not in any particular order? Any card? Any card?
Ivan had devised a starter activity where learners working in groups would need to match cards, rather like in a game of dominoes. To do this, they would need to draw on prior knowledge and make connections between ideas they would later draw on in exploring the motor effect.
Cross each other, cross each other.
Yeah. Even I knew that one.
Okay.
The cards featured ideas connected with magnetic fields and currents.
No, that's not it.
That's because it's got pictures on them as well, and you have to match the pictures with the writing.
Yeah.
Like the different powers and things like that.
And I like that as well because I'm more of a visual learner than to read it. Yeah, so it's a mix.
I believe that this is a good recapping tool. What did we do last week? Oh, here's a short activity. Spend 10 minutes, put the dominoes.
So you were basically using it to check their sort of understanding.
That's right.
Yeah.
It's more of a reminder of what you've done.
To get you started.
To get you started, yeah.
Okay, it can go like that, yes. Yeah, that's a starting point.
There's a loop, something pattern, magnetic field pattern.
Two south poles are placed together, they repel each other. What is on there?
As well as listening to see what kinds of things learners could most easily recall, it was also an opportunity to think about how and if differences of opinion could be resolved.
What is it? Never, lines of magnetic force never cross each other.
Oi, what do you have there?
Yeah. The patterns helps us identify the direction of movement.
Okay, magnetic field patterns. Which one, that one?
Oh, both magnetic field patterns go together, yeah?
Do you think so?
Yeah.
No.
No, they wouldn't go together.
They do.
Yeah, there you go, a magnetic field pattern.
Okay, then.
It was interesting to see some negotiation or in one instance a very clear non-negotiation.
When they start thinking and developing those sort of attributes for themselves, that's when we can say perhaps we're starting to get the message home to them.
To not just say what is the answer, but to justify it.
Yeah. That could go there.
Say what you see.
If a student could go around the general patterns of the magnetic field, and he might then get to this point, but then he can't grasp the concept between the magnetic field around a current-carrying conductor. And at that point, we could put him into a more practical situation where we get the battery, we get the conductor, we get plotting magnets, and then he can generate his own magnetic field and see that it is circular.
Now, based upon the work that you've done with the cards, with the dominoes, we want you to make a small motor out of the components that you've got.
The idea was to see how learners would express their thinking to each other as it developed.
Not sure.
Identifying as they did so the interaction between magnetic field and current. First, What ideas did they draw on initially?
What's the first sort of thing you've got to look at in an electric motor? What do we need?
Well, we need to create an angular motion.
Yeah.
Well, we need to do that from the magnet force we've got somehow.
One of the girls had wrapped the cord and the nail around each other because that was a theory, but obviously wouldn't work. So then we had to try it a different way.
You're going to need the wire for something.
It was fun to do. It took a while for us to figure it out.
Because last lesson we worked out the theory like behind it, and it's different working out the theory than to actually see it happening and going. That's when you see like how it works and the different parts.
And like when you're doing it practically, you don't just learn the main points you need just for the exam. You learn like, some side bits which help you understand it.
With a wire in there, you can go here and you can fix it.
It's going the other way.
It's good. It's spinning the other direction.
Yeah, it's going anti-clockwise. Yeah.
Because the current is flowing in a different direction. It's worth a try though.
Let's try.
No, because the paper's not conducting the electricity.
Yeah.
You need to put the paper through the nail. No, it should spin.
Learners were listening to other learners' ideas. One of the ways in which that is useful is if it provokes learners to think about their own understandings.